Hello students, today in this lesson I am going to discuss effective resistance of network. That is a very important topic, and when we deal with chapter current electricity, this topic becomes very important. And this topic is also very important as far as competitive exams are concerned. So here in this video lesson I will discuss how we can calculate effective resistance of a network. And before that, in our previous video, I have discussed with how we can find out effective resistance in series combination and effective resistance in parallel combination. These two formulas we will directly use here. What is effective resistance in series combination and what is effective resistance in parallel combination. And I think you all are remembering these two formulas. One is for series combination and other is for parallel combination. So we know that in series combination, the effective resistance Rs of any network is given by R1 plus R2 plus R3 and so on. Whenever resistors are connected in series means one by one, that just we are going to discuss. Whenever resistances are connected end to end, then this is known as series combination. For example, I am drawing the diagram. These three resistors, here it is R1, here it is R2 and here it is R3. So here we can say this R1, this is R2, this is R3 and these are connected in series. They are connected one by one. This type of combination is known as series combination. But when they are connected in parallel, the parallel combination is like this. When all the resistors are connected in such a way that first end of all the resistors is connected at a point and the other end of all the resistors are connected at a different point, then this is known as parallel combination. Let us suppose this point is A, this point is B. Then we can say these three resistors, that we can say R1, R2 and R3. They are connected in parallel. In our previous video, we have discussed how we can find out the effective of these three resistors, and the final answer comes to be 1 upon Rp. Where what is Rp? Rp is the effective resistance between A and B of these three resistors. So how we can calculate this? 1 upon Rp equals to 1 upon R1 plus 1 upon R2 and plus 1 upon R3. So these are the two key formulas which we are going to discuss in this video lesson. By the use of these two relations, we will find out effective resistance of complex networks. It means complex means when the resistors are connected in series as well as they are connected in parallel, then how we can find out the effective resistance, that I am going to discuss in this video lesson. So remember these two formulas R1, R2, R3. Number one is for series combination, other one is for parallel combination. These two formulas we will keep in mind whenever we are solving such type of question. One more point related to this. Let us suppose all the resistors which are connected in series are exactly same. It means if they are identical. Let us suppose I am writing first resistance is having value R, other is also having value R, other is also having value R, and there are n resistors, there are n resistors having same value R each. Then effective resistance in series combination can be written as NR. This is the effective resistance in series combination, Rs equals to NR. Similarly, if the resistors which are connected in parallel are having exactly same value, it means they are just identical, then we can again use a short trick, or we can say new formula, that is 1 upon Rp equals to 1 upon R plus 1 upon R plus 1 upon R and so on. We can again say n upon R. 1 by R, 1 by R, 1 by R, 1 by R. The final answer will be n by R. But this is the value of 1 upon Rp. Therefore, we can say Rp equals to R by N. So these two formulas will be again very important when we solve complex networks. Rs equals to Nr. It means directly we can multiply by the number of resistors if they are having same value. Similarly here Rp equals to R by N. It means whenever identical resistors are connected in parallel, then effective will be R by N, where N is the number of resistors. For example 3, 4, 5, 6, etc. That is R by N. So in series combination R is equals to Nr. In parallel combination Rp equals to R by N. So here is, by using these two formulae we can also write two important questions. First, what is the ratio of Rs to Rp? It means series resistors to parallel resistors. By solving this, the ratio comes out to be N square ratio 1. And similarly, if the question is asked what is Rp by Rs, so you can divide, we can get 1 by N square. So this is Rs by Rp, N square ratio 1. This is Rp by Rs, 1 by N square. Now we are going to discuss the effective resistance in different circuits. These two formulae you will keep in mind. So I am taking different questions related to the combination of resistors. First question, so that we can easily understand this topic very clearly. First question is very easy, but it is again important to understand the concept. A, B, there are 2 points A and B, and this resistance is of 5 ohm, this is of 1 ohm, and this is of 4 ohm. So here we can easily understand these are the 3 resistors, they are connected in series. No need to write the formula, we can write 5 plus 1 plus 4, the answer will be 10. No doubt, very easy question. This is series combination. Similarly, I can take second question. The same resistors are connected in parallel. I am drawing the diagram so that you can easily understand. We can change the value or we can put the same value. Let us suppose here it is 1, here it is 2, here it is 3. 1, 2, 3. This is A and this is B. The question is this. What is the question? Find out effective resistance between A and B. So here from this diagram it is very clear that they are connected in parallel. Therefore, we have to use the formula 1 upon Rp equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we can use 1 by 1 plus 1 by 2 plus 1 by 3. I have put the value of R1, R2, R3. This is first resistor, this is second resistor, this is third resistor, and having value 1 ohm, this is 2 ohm, and this is 3 ohm. We can take the LCM. The LCM will be 6. So here we can write 6, here it will be 3, and here it will be 2. Finally we will get 11 by 6. And this is the value of 1 upon Rp, not Rp. So this is 1 upon Rp, 1 upon Rp equals to 11 by 6, and therefore Rp can be written as 6 by 11. This is the parallel combination. First is series combination, other is parallel combination. I think this is very clear. Now I am discussing third question. Very easy. Here it is a 2 ohm resistor. And now there are 2 resistors. This one is of 6 ohm and this one is of 3 ohm. Here is point A, here is point B. Now there may be 3 questions. This point is A, this point is B. I can also mark a point P here. If question is asked what is effective resistance between A and P, answer is only 2 ohm. Effective resistance between A and P, answer is only 2 ohm. Effective resistance between P and B, then this will be the answer only. Now we have to solve what will be the parallel combination of 6 and 3. So if question is asked effective resistance between P and B, then we can solve by using this method. 1 upon R equals to 1 by 6 plus 1 by 3. We can take the LCM. 6, here it will be 1 plus 2, this is 1 upon R. And if we solve this, we get R equals to 2. So it means effective resistance between P and B is 2 ohm. Effective resistance between A and P is also 2 ohm. But if the question is what is effective resistance between A and B, then we have to draw this diagram again. How? This is 2 ohm, already mentioned. Here it is point P, and just we have solved that parallel combination of 6 ohm and 3 ohm is 2 ohm. So that we can also write here. This is also 2 ohm. And here is point B. Now you can easily understand these 2 ohm and 2 ohm are connected in series. Therefore, final answer resistance between A and B will be 2 plus 2, that is 4. I think it is clear. Question number 1, question number 2, question number 3. By using step by steps, we can solve the question. Now I am discussing question number 4. Next question. I am slightly increasing the level of the question. This is very important question, and by using this question we can learn so many concepts. Here are the 4 points A, B, C, D, and there are 5 resistors. Let us suppose this is of 1 ohm, this is of 2 ohm, this is of again 1 ohm, and this is of 5 ohm. This resistor is of 5 ohm. 1 ohm, 2 ohm, again 1 ohm, and 5 ohm. And here it is a resistor of 3 ohm. So that means there are 5 resistors A, B, C, D. These are the vertices of a rectangle, we can say. And here are 5 resistors 1 ohm, 2 ohm, 1 ohm, 5 ohm, and 3 ohm. And we have to find out effective resistance. But whenever such type of question is given to you, find out effective resistance of this network, terminal points must be given to you. Between which 2 points we have to find out effective resistance, and depending upon that there may be different parts in this question. Question is single, but there may be different parts. I am discussing different parts worldwide. For example, you may be asked that find out effective resistance. I am using the word effective resistance. Find out effective resistance between point A and C. It means our question is this: what is RAC? So RAC does not mean that only you give the answer 3 ohm. Sir, it is 3 ohm. No. Here we have to find out total effective resistance or net resistance between point A and C. And now we have to closely watch this circuit. This point is A, this point is C. Between A and C there is one resistor 3 ohm, that is clearly visible. I am drawing the diagram again. Here it is point A, this is point C, and this is 3 ohm. There is no confusion in this resistor. This is directly connected between A and C. But A and C are also connected by some different resistors. Therefore, we have to also include that resistors. Now, if we see this path, you can easily see A to D and D to C. If we see this path, it is clear that 5 ohm and 1 ohm are connected in series. You can easily understand. Here it is 5 ohm, this is 1 ohm. They are directly connected in series. This 1 ohm and this 5 ohm, they are directly connected in series. Then for series, you can easily find the answer directly. Here it is 5, this is 1, net answer will be 6, and this I am attaching like this. Let us suppose this is 6 ohm. What is 6 ohm? This is the effective resistance from ADC. This is 6 ohm. Now we consider this side. Here it is A, this point is B, this point is C. Again there are two resistors and again they are connected in series. Therefore I will mention this, and this is again also 3 ohm. So here we can easily understand this is 3 ohm directly. 1 ohm and 2 ohm they are series, but for AC they are connected in parallel. This is 3 ohm, and here it is 5 ohm, this is 1 ohm, again this is 6 ohm. Now we can easily understand these are the 3 resistors, they are connected in parallel. Therefore effective resistance 1 upon R equals to 1 by 6 plus 1 by 3 and 1. And finally you get, here it is 1 plus 2 plus 2, that is 5 by 6, and therefore R equals to 6 by 5. This is the effective resistance, but between which two terminals? A and C. So this is the concept of terminal points. Here if we have to find out effective resistance between A and C, we have to concentrate on A and C. If we have to find effective resistance between A and B, then the whole concentration should be between A and B, and we have to reduce whole the circuit between A and B. So this is resistance between point A and C, effective resistance between point A and C. This is 6 ohm, this is 3 ohm, this is 3 ohm, and all are connected parallel. Now I am taking second part of this. A part I think it is very clear. In A part we have discussed what is effective resistance between A and C, and we have calculated by using this. Now I am discussing second question of this part. If we have to find out effective resistance between A and B, it means A and B are the terminal points. We have to reduce whole the circuit between A and B. Therefore, we have to find out effective resistance between A and B. And now if we closely watch this A and B, then here is one ohm resistor A and B. This is 2 ohm, this is 1 ohm, and this is 5. Some students may say that, sir, these 3 will be in the series. I am considering this. Let us suppose you are saying that all these 3 are in series, but no, it is not. Why? If we consider this 2 ohm and 1 ohm, there is also between this 3 ohm. Therefore, this 1 ohm and 2 ohm are not in series. But if we clearly see this, it is clear that this 5 ohm and 1 ohm are directly in series without any confusion. 5 ohm and 1 ohm are directly in series. And the effective of these two resistors will be in parallel of these 3. Just we have discussed in the previous question. 5 and 1 are in series, and effective of these two will be just parallel with this. So again I am drawing the diagram. In such type of question, we have to draw the diagram again and again, and that is known as method of reduction. We are reducing the circuit. One by one. This is A, this is B, here it is C, no change up to this is this. Here we have no change. Now this 5 ohm and 1 ohm are in series, just we have discussed in the previous part, and this 6 ohm will be in parallel. This part also we have discussed in previous part. 5 and 1, this is 6. Now 6 and 3, they are in parallel without any confusion. So we will take only these two parts. 6 and 3 both are in parallel. Both are in parallel, 6 ohm and 3 ohm. So we have to calculate the parallel. And parallel we can also calculate by using a short trick. Only that is valid only for 2 resistors. We can directly remember. For 2 resistors, I am showing this trick. 1 upon Rp equals to 1 upon R1 plus 1 upon R2. This formula we know very well. We can also write 1 upon Rp equals to R1 plus R2 divided by R1 R2 by taking this, and therefore Rp become R1 R2 by R1 plus R2. So by using this formula we can directly solve the parallel combination of two resistors without wasting any time. How direct? This is product. This we can say product, and this is sum. Here it is product and this is sum. It means product of two resistors and divided by their sum. So here it is 6 into 3, that is 18, and divide by 6 plus 3, that is 9. 18 by 9, the final answer is 2 ohm. You can also use this trick. So this is R equals to 2 ohm. But where 2 ohm? This is 2 ohm. Now after solving this, again we have to reduce the circuit. So I am mentioning the sign of equivalent. This circuit will be also equivalent to this. I am again drawing the diagram. This is A, this is B, this is C. Here it is 2 ohm, here it is 1 ohm, and no change up to this point. But the effective of these two just we have written here, that is 2 ohm. Now we can connect this 2 ohm here. So now you can easily understand what was the change. This 6 ohm and 3 ohm, they were connected in parallel. The effective of 6 and 3, that is 2 ohm, since they are connected in parallel, this is 2 ohm, and now this 2 ohm is here. Now again keep in mind, what is our aim? We have to find out effective resistance between A and B. Now A and B point are here. Now you can easily see this 2 ohm and 2 ohm are in series. Not all are in series because A and B are the terminal points. These are the terminal points. We have to find out effective resistance between A and B. It means without using this A and B, these two will be in series. And the series combination of these two will be in parallel with AB. That again I am using this diagram. Here it is A, this is B, and this is 1 ohm. Without any change, this is 1 ohm. And 2 ohm and 2 ohm, they are connected in series. Therefore effective will be 4. And this 4 will be in parallel with B. So now this is the final diagram, 4 and 1. And now I think you can easily solve this. These two are connected in parallel. Just we have discussed in new trick. R equals to. This R is R effective between A and B final resistance. This R is only this 6 and 3. And this is R AB equals to final resistance between A and B. So how we can solve it? 1 into 4 by 1 plus 4. Or that will become 4 upon 5. So this is the effective resistance between A and B. I think you are easily understanding. Again I am equaling this A and C. For A and C we have discussed in first part. Here for AB, these two are connected in series, 1 ohm and 5 ohm, effective becomes 6 ohm. Now this 6 and 3 are in parallel, and the parallel of 6 and 3 will be 2 ohm. Either you can use this trick or you can also use this formula. If we use this again, we get this 1 by 6 plus 1 by 3, LCM will be 6, here will be 1, this is 2, 1 plus 2, 3, 3 by 6, that is half, and again reverse or reciprocal, RB we will get 2. So this is 2 ohm. Now this 2 ohm is connected in series with this 2 ohm, therefore 2 and 2 become 4. And finally this 4 and 1 are in parallel, and therefore we can use the formula product by sum, 1 into 4 divided by 1 plus 4, that is 4 by 5. And now you can see this 4 by 5 is different from our previous answer. Previous answer is previous part, that part is A, effective resistance between A and C. It means here effective resistance may be different, here effective resistance may be different, here effective resistance may be different, here effective resistance may be different. In one question we can find out different questions. Again in one question I am discussing part 3rd. Let us suppose we have to find out effective resistance between A and D. It means these are two terminal points. Let us suppose A and D, these are two terminal points. It means this 5 ohm we will use at the last. We have to use this 5 ohm in the last. And first of all, we have to solve the circuit or reduce the circuit in such a manner that whole resistance comes between A and D. So I am drawing the diagram. The first diagram we can show. If these are two terminal points, it means we can use this path. This path is free. In previous question, terminal point was A and B. Therefore, we cannot use this A and B path previous. But here, A and D are the terminal points, and we have to find out effective resistance between A and D. Therefore, this two resistors A, B, C, they are directly in series. Therefore, series of 2 and 1, again it will be 3. But the diagram is like this. A, B, C, these points are as it is. Here it is 5 ohm, no change. Here it is 1 ohm, again no change. And this is 3 ohm without any change. But this 1 and 2, they are in series. Therefore, their effective will become 3 and we can add like this. Why we are using this type of diagram? Because these are connected between A and C. That's why this type of diagram. And now you can easily understand this 3 and 3 are in parallel. This 3 and 3 are in parallel. We have to find out effective resistance of 3 and 3. Therefore, what will be the effective resistance? 3 into 3 divided by 3 plus 3. 3 into 3 divided by 3 plus 3. Or that we can say 9 by 6, or that we can also use 3 by 2. And this we can again use by some trick. Just in the starting we have discussed that whenever resistors are identical, it means having same value, then for parallel combination we can use the formula R by N, where N is the number of resistors. Here what is R? 3. How many resistors? 2. Answer is 3 by 2. If there were 3 resistors, 3, 3, 3, they are in parallel, then answer will be 3 by 3, that is 1 ohm. So here it is R equals to 3 by 2 ohm. This R is not the final answer. This is only the resistance between A and C, or we can say resultant of these two only. This 3 and 3, it will be 3 by 2. Now I am again reducing the circuit. Here it is point D. This is C, this point is A, and between this A and C, the effective resistance is 3 by 2. Here it is 1, no change. This is 1, this resistance is 5 ohm, again no change, and this is 3 by 2. So this we can say this is step first, this is step second, and finally step third, we will get the answer. Now you can easily understand A and D are the terminal points. Therefore, this 3 by 2 and 1 will be in series. They are in series. 1 and 3 by 2 are in series. 1 and 3 by 2. Therefore, effective resistance of 1 and 3 by 2, that is 1 plus 3 by 2. Or that we can say 5 by 2. For this resistor, 1 and 3 by 2, that we can also mention here, slight different, so that you can differentiate this. RS means series of these two. 1 plus 3 by 2, that will be 5 by 2. And now after getting this 5 by 2 ohm, the final diagram may be like this. This point is A, this point is D, without any change. And there is some other resistor like this. This point is A, this point is D. Here it is 5 ohm, and in this side it is 5 by 2. And now you can easily understand these two are again connected in parallel. Now we have to use the formula 1 upon Rp equals to 1 upon R1 plus 1 upon R2, or we can again say product by sum R. that is final R, effective resistance between point A and D, that we can say RAD. I am using the formula product by sum 5 into 5 by 2 and divide by 5 plus 5. So here we get this 5 into 5, 25. Divided by 2, this 2 will be cancelled out by this LCM 2. If we multiply this 2 into 5, that is 10 and this is 15. 2 into 5, 10, 10 plus 5, 15, and here is 5 into 5, 25, and this 2 will be cancelled out by the LCM in the denominator. And now finally we can say 5 by 3. So here we can see that in third part the answer is different, in second part the answer was different, and in first part again answer was different. It means by using such type of question you can solve so many questions. So I think you will be easily able to solve this type of questions. And next question I will discuss in my next video.